Welcome back, everybody. So, which of the following is quadratic? Now, first off, Chapter 9 is all about quadratics, right? Chapter 9 is all about quadratics. In terms of a graph, it's a U-shaped graph. That was all of Chapter 9, U-shaped graphs, and how do we work with them? How do we solve them? How do we do everything that we possibly can with them? The first part of Chapter 9 was all about graphing, and the second part of Chapter 9 was all about solving. We've got graphing, and then we've got solving, okay? So that's what we're going to review. We're going to review how to graph, and then we're going to review how to solve. Now, based on an equation, how do you tell when something is a quadratic? Based on an equation. Not necessarily y equals. What should it have if it's a quadratic? The x squared, right? The x squared. So, is A quadratic? No. Is A quadratic? No. Is B quadratic? Yes. Is C quadratic? Yes, it has the x squared. Is D quadratic? No. Okay? So basically what you know from this example is that things with an x squared are quadratics. Okay? Things with x squareds are quadratics. And it has to be just an x squared. It can't be an x to the third. It can't be an x to the fourth. It has to have just an x squared. That's the biggest power it should contain. Okay? All right. Let's talk about domain and range. Now remember, domain is the x values. Range is the y values. In terms of domain, for both of these examples, okay, or really all quadratics, what is the domain for all quadratics? All real numbers, because it will go on forever to the left and to the right. So it's an all real numbers here and an all real numbers here. Okay. It's an all real numbers all the time. All the time. Now, for the range, it always depends on whether it opens upward or whether it opens downward, right? If it opens upward, then the range is that minimum point and above. If it opens downward, then it's that maximum point or below, and you're always looking at the y value. So, is this going to be a y is less than or equal to, or y is greater than or equal to? Less than. Because this is a maximum point. I want all points below that line. So y is less than or equal to, and then you just pick out the y value of the coordinate. Looks like it's a 6. Y is less than or equal to 6. There's my range. Looking at the second one here, do you see how this is a minimum point? So therefore, it's going to be all points above that value. So the y value there is -8. So this is actually going to be the greater than or equal to -8. A domain is always all real numbers. Range depends on whether it's a minimum or maximum point. Okay? All right. If I want to identify where the axis of symmetry is, well, somebody remind me. Where do I look to find the axis of symmetry? Baker?
The middle.
The middle, the midline of the graph. So I'm going to draw in my dotted line here. The midline of the graph, where does it look like it falls? 2. Remember that any axis of symmetry should be an x equals a number. Okay, x equals 2 would be my axis of symmetry. So we learned about maximum or minimum point. We learned about axis of symmetry. Remember that the vertex always lies on the axis of symmetry. That x value is going to be the same thing. Okay? And we always know that it's symmetrical about that axis of symmetry. Then we got into this question where we had to graph that A, B, C, D, E, right? The parts where I have to say, okay, find the axis of symmetry, find the vertex, find the y-intercept, and then let's graph the function. I don't know why I didn't do this on this one, but remember, this is the point, this is the one where I have to do 2 additional points as well. Now, if you have your note cards, this would be a great time to get out your note cards because I'm going to give you a couple formulas to use. Or if you don't have your note card, maybe start making yourself a list of things to put on your note card. First thing that I would put on the note card is the axis of symmetry formula. Okay, the axis of symmetry formula, that's x equals, does anybody remember it? Well, what do you think? Oh, no, that's the quadratic, that's the full quadratic. It does start with a negative b over, though. Negative b over 2a, negative b over 2a. That's the axis of symmetry formula. So, by seeing that we don't really know that one, again, that would be something that you should put on your note card. X equals negative b over 2a. All right, so if it's negative b over 2a, that means my axis of symmetry is, in this case, well, my a value is 1, my b value is negative 4, and my c value is negative 5, right? We see that here. It's in standard form. This is a, this is b, and this is c, right? All right, well, so finding the axis of symmetry here is x equals negative, and then I plug in my b value, negative 4, divided by 2 times 1. Yeah, I get that there's a double negative in there, and that will cancel out. I'm just showing you here what it would look like when you plug it in. So negative and a negative makes a positive, so 4 over 2 is 2. X equals 2. So let's go ahead and just start graphing this. So I put my dotted line at 2. Kind of wavy dotted line, that's okay though. So there's my dotted line at 2. Now I'm going to find the vertex. Let's plug the vertex back in, and that's what we do here. We take that axis of symmetry and we plug that y value, that x value back in. 2 squared minus 4 times 2 plus 5. 2 squared minus 4 times 2 plus 5. All right, so that gives me a y is equal to 4 minus 8 plus 5, which that's negative 4 plus 5, 1. That means my vertex is the full coordinate 2, comma 1. Right there. There's my vertex. How do you know where the y-intercept is? What part do you look at for the y-intercept? In terms of the equation. What's the y-intercept in this graph?
Would it be negative 5 here?
It's negative 5. Yeah, it's negative 5. Because I have, now this should point up though, because it's happy. Oh, look, well, hold on a minute. Look at this. Look at that. Silly Mr. Labrick. I know. See, I'm not a robot. See, negative 4, that should be a negative 9. There we go. Negative 9. Negative 4 minus 8, negative 4. Okay, minus 5. I was going to say, this should point up. How do I, that's a good point to bring up. How do I know this should point up and not down? The a value is positive. Remember, this is a happy parabola. When the a value is positive, it points upward. When the a value is negative, it points downward. So that was kind of throwing me off there because I was like, wait a sec. That vertex can't be higher than the y-intercept. So 1 comma negative 9. Now it makes sense that when I put my y-intercept here, which is my c value at negative 5, okay, that makes a little bit more sense because now it's going to point upward. Now remember that we can flip that over the axis of symmetry, right? We can flip that over the axis of symmetry so we have a point over here as well. It didn't ask me to do the 2 other points, so I guess I won't. We'll just plot it like that. Questions about that? Okay. All right, go ahead and write this one down for yourselves. 2x minus 5, 3x plus 1. So that was what we've just done. Everything up until now has been the first part of chapter 9. The second part of chapter 9 is all about how we solve these things. We spent 4 sections on how to solve them. We solved by factoring. We solved by using square roots. We solved by the quadratic formula. And we solved by completing the square. We learned 4 methods to solve quadratics. The factoring method relies on the zero product property. All that means is that I could set each piece, like this one's pre-factored for us, set each piece equal to 0, and that will give me my 2 answers. It creates for me 2 mini equations that I can solve for my answers. So let's do that. We add the 5. We get 2x is equal to 5. We divide by 2. We get x is equal to 2.5. We subtract the 1. We get 3x is equal to -1. So x is equal to -1/3 or -0.3. And those are my 2 answers. That means this crosses the x-axis at those 2 locations. Right? That's where, remember, that was the whole end goal of the second half of chapter 9. Where does it cross the x-axis? It crosses the x-axis at where these pass through the x equals 0 points. Okay. All right. This would be solving by square roots. How do I know that this is a solving by square roots? Well, do you see a b term? No, there is no b term. Remember that to solve by square roots, you should not have a b term. This is just x squared minus 36 equal to 0. And solving by square roots is really quite easy. All you do is just solve directly for x. You add the 36 over to the other side. And again, you should be writing this down with me. You add the 36 to both sides. And then, to undo the square, you take the square root. So x is equal to the square root of 36. Now, what should I write in front of my square root? The plus or minus. Don't forget about the plus or minus. So x is equal to plus or minus 6. Now, remember what that means. What does that plus or minus actually mean? That means that positive 6 is a negative answer, or negative 6 is an answer. Like if I think about, for any equation, I should be able to plug in my answer, right? So positive 6, does positive 6 work? Yeah, 6 squared is 36, minus 36 gets us back to 0. Does negative 6 work? Yes, because when I square negative 6, I get back to positive 36, minus 36 is 0. Okay, so that's the solving by square root method. Okay, that's the first method. The second method is solved by factoring. Now, we reviewed factoring yesterday, but now we're going to take it a step further and say, okay, we're going to solve by factoring. This is the second method that we learned. So let's start with our factor tree. Not factor tree, but our flow chart. Let's take a GCF first. So I'm going to remove my x, actually a 3x coming out. Take my 3x coming out. And that leaves me with a 4x minus 1 equals 0. See, I factored the left side, and I factored it by GCF. Now, once you have it fully factored down, you use that zero product property and set each factor equal to 0. We say 3x is equal to 0, and 4x minus 1 equals 0. Set each piece equal to 0. And then we solve, and the left side's pretty easy to solve. I divide by 3. 0 divided by 3 is 0. And then we add 1. 4x is equal to 1. And then we divide by 4. X is equal to 0.25. Now, you'll have to be careful on the exam, especially if it's in the multiple choice portion. It may be as a decimal or it may be as a fraction. So So you just got to be aware of that. If you get an answer, a decimal answer like 0.25, just know that in the multiple choice responses, if you see 1/4, that's the same answer. You just got to know that they could be transferred from one to the next. If it's a free response problem, if it's a short answer problem, you can do whatever you want. 10x squared minus 13x minus 3. Let's go ahead and write this one down.
This is all by factoring.
Yep, this is solved by factoring again. The issue with this one, there's no GCF. So that means, is this an easy type or hard type? Hard type. Okay. So there's no GCF. I'm going to factor this by hard type. So this is a good refresher on what we did yesterday too. First times last. Negative 30. What are the factors of negative 30 that add to get to negative 13? Negative 15, positive 2. Please don't say 10 and 3. Please don't say 10 and 3. I want to get a negative 30. So therefore, I need a negative 15, positive 2. 10 and 3 would get us a positive 30. Because it would be 10 times 3 or negative 10 times negative 3. All right. So it's negative 15 times 2. Let's rewrite. Let's factor this. Minus 15x plus 2x minus 3. And then we factor by grouping. We GCF the first part, leaving a 5x, which leaves us with a 2x minus 3. And look at that. That's the only thing I have left in my second set because there's no GCF. So let's pull out a 1. Remember, when you don't have anything to pull out, you pull out a 1. Leaving us with exactly the same thing. So that means we get the 2x minus 3 as one of my factors, and then the 5x plus 1 is the other factor.
You have to equal to our answer.
Now we have to set them both equal to 0 and solve. Yeah, so this is a lot of work because now I'm not done yet. I have to say, okay, 2x minus 3 equals 0, as well as 5x plus 1 equals 0. That's why I was writing equals 0 the whole way, because that will remind me to solve at the end. I've got to set each piece equal to 0. If you don't, you're not going to get your final answers properly. You add the 3, 2x is equal to 3, and I divide by 2. X is equal to 1.5. I subtract the 1. I get 5x is equal to negative 1. I divide by 5. X is equal to negative 1/5 or negative 0.2. So quite a lengthy problem on that one, right? It takes a difficult factoring problem and then on top of it asks you to solve. Okay, so we've gone over factoring and we've gone over square roots. Okay, we've gone over factoring and we've gone over square roots. Actually, we've already done a problem like this. Let's see. Oh, let me ask you this. This is a good one to talk through. What would I say with something like this? Yeah. So what would I do? How would I solve for x? Square root negative 9. You can't do the square root of a negative. You can't do the square root of a negative. This would have been x is equal to plus or minus the square root of negative 9. And if I go to take the square root of a negative, what happens? You can't do it. No solutions. Okay? Be careful with that. When you go try to square root a negative, there's no solution. Why is that the case? Well, try to think of something that you could plug in for x to make that equation work. There's nothing. You can't do that. Okay? Like if you try to plug in 3, okay, that gets you positive 9. You try to plug in negative 3, that gets you positive 9 again. There's nothing that if you square gets you to a negative number. Okay. All right, so here it is. Let's do the quadratic formula. Now again, I had you memorize it on your test, but I would very much expect that you put this on your note card. Okay, man, this would be big and bold on my note card. What is the quadratic formula? X equals the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. That's my quadratic formula. Again, something that you should definitely put on your note card. Okay, so what does that mean? That means a is negative 3, b is positive 5, and c is positive 2. X equals the opposite of b. So it was positive 5, let's say negative 5, plus or minus the square root of. And then I've got 5 squared minus 4 times a, which is negative 3, times c, which is 2. All divided by 2 times negative 3. Where do we go first? Inside the square root, inside the radical. That thing that's called the discriminant. The discriminant. So let's go underneath the radical and do that first. Let's see. I've got 5 squared minus 4 times negative 3 times 2. So underneath the radical, I've got 49. X equals negative 5 plus or minus the square root of 49. All divided by, and I can do this step now, 2 times negative 3 is negative 6. Heck, why not? I'll just make that 7 now. Square root of 49 is 7. Negative 5 plus or minus 7 all over negative 6, which means that I say negative 5 plus 7 over negative 6 and negative 5 minus 7 over negative 6. Remember that plus or minus breaks it up into 2 different solutions. The plus and then the minus. So negative 5 plus 7 is positive 2 over negative 6, which is negative 1/3 or negative 0.3, repeating. Negative 5 minus 7 is negative 12 over negative 6, which gets us 2. So my two answers are negative 1/3, negative 0.3, or 2. Again, one that I would definitely put on your note card. You know what I'm going to do? Instead of doing this one, I'm just going to give you a freebie here. I'm going to do problem 39 with you. Because our last method of solving is called completing the square.
Wait, so solve by quadratic formula is one too?
Yeah, so we got factoring, square roots, quadratic formula, and then completing the square.
Go back up to that problem.
Yeah. Is there something you want to ask about? Just writing it down.
I'm just writing it down.
Okay.
You go a little farther.
Yep.
Okay.
Okay, so I'm just going to write down 39 down here while we're waiting. 39 is x squared plus 8x is equal to negative 15. You get it?
Yeah.
Perfect. All right. And this says solve by completing the square. So remember the process for completing the square. First step, variables to the left, constant to the right. Is that done? Yeah. Second step is leave a little room. Fill in my blank. Now, does anybody remember what fills in the blank in this problem? Somebody can do it. I know this. You got this. Not 8. Trip, you got this. Is it 4? You're close. 16. Remember, it's b over 2 squared. b over 2 squared, right? So it's 8 divided by 2, which is 4. And then I square it. So 16 gets added to both sides. And whatever you do to one side, you got to do to the other. Okay, remember that is b over 2 squared. B term is the one that's next to the x. All right, and then we just finish it out. Well, this factors. Remember, that always factors into b over 2. We're doing this, divide by 2. That will always factor into x plus 4 squared in this case. And on the right side, I just get 1. Negative 15 plus 16 is 1. I square root the opposite side. What's the square root of 1? Right? And then we write the plus or minus 1, right? Subtract the 4. So that gets me x is equal to negative 4 plus or minus 1. And that gives us our two solutions. Negative 4 plus 1 is negative 3. Negative 4 minus 1 is negative 5. That's completing the square. Remember, let's run through the process one more time. Variables to the left, constant to the right. Good, done. You take half of your middle term, and then you square it. And that's the part that gets added to both sides. So say this was a 10. You'd be adding 25 to both sides. Half of 10 is 5, squared is 25. Say this was 50. No, let's not do that. Let's say this was 16. Half of 16 is 8, squared. You'd be adding 64 to both sides. Then you combine like terms on the right side, and then you factor down the left side. Remember that you don't even have to perform the factoring. It will always just be b over 2 in there. You square root the opposite side. Square root 1, you get 1. Right, plus or minus in front of it. And then subtract over the 4, you get negative 4 plus or minus 1. Which means negative 4 minus 1, or sorry, negative 4 plus 1 is negative 3. Negative 4 minus 1 is negative 5. Good? All right. That's where we'll stop for today. I'd like you to use the rest of the time. I know it's only 7 minutes, but I want you to utilize your time. I want you to work on the questions from chapter 9. So tomorrow, just to be very clear, tomorrow's questions that are due 27 to 41. 27 to 41 is due tomorrow. 27 to 41. I'm okay if you just sketch it, because I think there's only one graph. That's it. So I'm okay if you just sketch it on the paper.